podcast. Well, I guess it's not a podcast; it's our live show, right? So as everyone's joining in, just a reminder, we are the folks at JuliaHub. We're building out this agentic AI system for modeling and simulation. And what we're going to be doing today is we're going to be going through all sorts of things to make these quadrotor models better. I mean, you can already see that we've updated this quadrotor model so that way it's being controlled with a DualSense controller, a PlayStation controller. We'll walk through all that in a second here. But we should probably introduce our new guest on here because we got someone new on for the first time. So Ben, you wanna say hi?
Hi, I'm Ben Chung. I'm a modeling and simulation consultant with JuliaHub. It's great to be with you all.
Yeah, so we got Ben on, and he's going to bring us some. Last time we were on the show, we had some requests to use real data and connect our quadrotor model to that. So we got a real engineer who has seen the. Well, you've seen the real world, right?
It allegedly exists.
Yeah, yeah. I mean, I'm trying to deal with it right now. This is a very uncomfortable territory for me out in the wild, suburbia of the United States. But we'll bring in data from the real world, and we'll see what happens when we mix this with our quadrotor models. But yeah, Anshul, you might want to describe a little bit what you're doing right here.
Yeah, yeah.
Sort of
So
update.
this is this was supposed to be. Let me see if I can. Here we go. So I've got this PS5 controller, which is hooked up to my laptop, and I am controlling the waypoint of the drone using the PS5 controller. So last time we tried to do this using the keyboard, but that was extremely annoying. So we figured, okay, try with an actual game controller this time. Um, yeah, I don't think the agent did a very good job of getting the command set right, so I'm gonna give it some feedback there. But you can see that there's a bunch of controls here, right? The left stick lets me move in X and Y. The right stick is supposed to help me change sort of planes, but it doesn't quite seem to work the way I expected it to. Um, and then I can change the wind intensity, right, with pressing the trigger buttons. And I can also unpause, which would be quite helpful.
Yeah, so
And so,
let's make sure we should probably start by then describing the model in full here, so that way everyone who didn't see
yes,
the last live stream we had is on the same page of what this what's all in this model, what's it all about. And I think because I can see Ben's looking there, he's just like, "What do you
yeah,
guys?"
yeah, yeah. So, all right. So I'm going to ask the agent to describe the model for me. Let's see how well it does. Describe what this model is doing. Assume I don't know anything about it.
Yeah, so if anyone didn't know that we have the voice dictation set up, so you could use that with the agent, and that is uh, that is our preferred way to vibe code. Well, the preferred way is you
Definitely
have
bring
to have
some
the
good
Meta
vibe.
sunglasses on, right? You put on the Meta sunglasses and you put on
Ah,
your sunglasses, and it does the coding for you. That's the true style, but
that's true. That's true.
you're not
Well,
in
Chris,
California, so you don't understand.
Chris, that'll have to be you next time, right?
All right, yeah, yeah.
Yeah, yeah, yeah. All right, we got to try this now. Okay, so you can see the agent is sort of reading all of these Dyad files, which contain our model. So it's got the dynamics of the quadrotor, it's got the dynamics of the wind disturbance. Ooh, very cool. Okay, okay. All right, so it's a physics-based simulation of a drone. That seems correct. You can control in real time. So you're moving a waypoint, which is the sort of target of the drone in 3D space, and the drone has an autopilot which tries to fly to that waypoint automatically. The sticky point in this is that you have wind, which is military specification wind, government. This is government provided wind we've got going here, and so the drone's autopilot has to actually fight against the wind to make it to the waypoint that it needs to get to, and of course you're also moving that waypoint continuously. And yeah, there's a PID controller which has got a nested control loop. So Rajiv, do you want to say something about the control here? I really have no idea what this means.
Yeah, it's just a standard cascading PID controller for outer loop and inner loop control. So essentially, there's some PID gains to ensure that the position is being tracked well, and then some more to make sure the inner attitude control is being tracked well. I'm also curious. So while building this out, we spec this out with a model of a motor and saturation.
Hmm.
Has the agent sort of picked up on?
I don't know if we did. Okay. Do the motors have any saturation? But yeah, so well, theoretically, the controller's LED should also change based on how close the drone is, but we'll see that in a sec. Sorry, I'm using Opus 4.5, which is the latest model, so the agent can sometimes be a bit slower. That's just on the model provider and nothing we can do. But okay, so there is no motor saturation. All right, should we add some?
That would make it tricky for it to probably track your mouse pointer based on wind, right? It'll make it look more interesting and realistic.
Tricky is the spice of life.
Sure, yeah, why not?
All right,
let's add
let's go
some
for it.
saturation there.
All right, propose some saturation dynamics that would work for this.
All right, I made sure that our social media went out. We should be getting a few more people to join in this nice
Sweet.
morning. Yeah, zoom in on that code a little bit more. Let's see if we can.
Yeah. Let's see here. Yeah.
But I saw that as a PID controller with anti-windup.
Oh, so it's actually given us a bunch of options. Okay, so the first option is that you just clamp the outputs. We could do that. The second option is that you give the dynamics, the motor order dynamics of first order saturation.
Yeah, that seems more consistent with.
And then you can also, there's some, this option.
Okay, so the model that we're using right now is, it looks like it's gone back to the academic model, which is, it tracks the thrust and moment and not necessarily maps that to the linear, like, so just like a map of the RPM of the motors to the thrust and moment. And what it's sort of proposing right now in the recommended part is to change the thrust and moment control inputs to the angular velocities of the motors, and then saturate that, and then pass that as a linear map to give you sort of thrust and moment. Which
interesting. So this is this option 2 then.
Yes.
Gotcha.
And that was sort of what we landed on as sort of the next level of complexity. So option 2 is actually pretty good.
All right. That sounds good. That sounds good. Yeah, it's given me this option 3, which it's recommending, but like, All right. All right, let's implement option 2. And it also says it can also add anti-windup to the PID controllers.
Sure.
Yeah.
Yeah.
All right, also add anti-windup to the PID controllers. All right, in the meantime, I'm going to open a Claude Code.
And of course, we live dangerously.
Of course, we got to live dangerously.
That's the
it's
only
too
way.
Slow otherwise, it's too slow otherwise. I can't
shoot from the hip.
Yep. Alrighty, so there's a script, and there's this new thing. Look at this and propose a better control layout for the DualSense controller, because right now it's a bit tricky to work with. Don't actually edit the code yet, just make a plan.
That's not living very dangerously.
We have 2 AIs editing this code at once.
Yeah, he gave it all the permissions, and he didn't just
He's like, don't change anything.
My operating system.
Trust me, bro. Trust me, bro. That's all you need. All right, so it's created a motor the agent has created us a motor dynamics component here. And let's see what this is doing. Or better, I just view it like this. Okay, so you've got an input, which is the commanded total thrust and the commanded body moments, which is, I guess, like the components of the thrust. in
It's
3 dimensions?
yeah, the moment that needs to be supplied to the quad, and yeah, it's like mx, my, mz, and then the thrust is just.
Uh-huh.
Uh,
Yep, yep. All right, and so then it's got some internal variables. It's doing these calculations, and okay, interesting. All right, all right. Cool, that sounds good. Should I ask the agent to give us like a picture of what these motor dynamics look like in practice? Oh, it's already doing that. Okay. Well, you can see that it didn't figure out how to construct the model correctly. But it's going through the analysis now.
Yeah, so we have a little bit of downtime. I saw that a few more people joined here, and on some of our streams. Welcome, welcome. What we're doing is we are making sure that we can control our Quadrotor model, which is a model with government wind and all this stuff, and making sure that we can control it well with a PS5 controller, and then displaying the live simulation inside of a Mach-E window. Again, all generating everything through the Dyad AI system, plus some other live coding tools, and showing that, seeing how far we can get with all of it. So
Government
All
wind also sounds like a nice name for a punk band.
right. All right, so we've got this motor dynamics tests.png. All right. Oh, yeah, okay. All right, so let's see what we've got here. We've got the motor angular velocities. So motor 4 is a bit faster, motor 2 is a bit slower, which is interesting. Your total thrust output is sort of capping out at a little less than 10 newtons. And you can see that we've got the saturation response also on the body moments. All right, so this looks pretty good.
Okay, now do we plug this into the PS5?
Yeah, so this is
Simulation?
now, it's saying that the motor angular velocity, sorry, the motor dynamics are working correctly. It's now trying to add anti-windup to the PID controller. And so you can see that it's had to add already some guess values because modeling toolkit ran into some trouble, but it's added the guess values. It's trying this out now. And Claude has also suggested a nice control schema. So I'm actually going to have it, yes, implement the changes. No. Yeah, sometimes this dictation doesn't quite get what you wanted it to. Huh, interesting. Alrighty. You guys seeing this? We've got the DT was forced to be extremely small, and the simulation has actually aborted. And so the agent is now investigating this instability issue, right? So it's gone, it's run a simulation, it's seeing what's going on here, it's looking at the equations, right? So the agent is actually able to reach into the model programmatically and get all of the equations out, look at them, play around. So it's found, okay, so it's found that the test harness has an algebraic loop and seems to be trying to correct that now. All right, all right. Meanwhile, simultaneously, Claude is working on our control scheme. All right, what's this doing now? Okay, this is just checking that the solution was correct. All right, looking good. Seems to have solved. So this is, all right, this is a pretty complicated plot it's making. All right, so it looks like it's created a new plot. And let's see here. All right, so this is showing that, okay, so with anti-windup, you can see the integral state stays pretty close to 0. Without anti-windup, it just starts blowing up. And controller output seems to be broadly the same.
That's what we'd expect from a saturated output.
Sweet. Yes, integrate the motor dynamics into the full Quadrotor system. I'm just going to commit first.
You might want to specify that this is for the interactive PS5 sim, because we have a bunch of scenarios that we did right before that.
Oh, that's true. No, but that's true. That's true. I think it into the full Quadrotor system that uses the DualShock, not DualSense.
Yeah, so I just want to remind the viewers, now we got a few more people that just joined in here. Anyone who wants to slam in anything into what we're doing here, we're also taking live comments or whatnot. So please feel free to give suggestions. Doesn't mean that we're going to take every suggestion. Doesn't mean that we're ready for every suggestion, right? Someone asked for real data last time. We're like, okay, we had to go get some real data. But if there's anything that you're seeing along here that you're like, I really want to try this to give this control scheme or something, just please slam it at us. And we want to kind of just see where this goes. Yeah, so I'm sorry, give a little bit of a summary of what you got going on here, Ben.
Yeah. So what we've got is we're integrating some more realistic motor dynamics into the drone. So the drone is going to be the motors are going, the thrust that comes out of the motors is going to saturate at some point, right? There's a point where no matter how much you spin more, how much you increase the RPM of the motor, you just can't get more thrust. And so that's what the Dyad agent has been doing. And I've also had so we've got a PS5 controller here, and I've also had the input mapping from that controller changed a bit to be a bit more intuitive. And yeah, the agent is currently just running these simulations and making sure that everything works.
So the important change, from my understanding, is that the Quadrotor in the interactive simulation before had just infinite thrust and moment to sort of play around with, and that's why it tracked everything so beautifully. And now,
all right. So now you think we're going to see it struggle a bit?
Yeah. Now when we are in what was it called, storm mode?
Yeah, storm mode. That's our heavy wind mode is called. All capitals cases storm mode. Yes. So when we're running the model in storm mode, we should see it no longer able to keep with the set point.
Storm mode indeed. Okay, so this is now running the script for me. Keep an eye out for when that pops up.
So speaking of drones, have you seen the drones that have been the stars of the Olympics? All those cool drone footage of the different events.
I have not been watching the Olympics. I'm sorry, I'm a bad citizen of the
Yeah.
world.
Well,
And so my type of sports is very different than the winter sports. But I mean, when people tell me about skiing, right, they tell me things like, oh, like I love skiing. I've been going for 20 years, and yesterday it just broke my hip, so I'm gonna plan my next ski trip for next winter, right? So like after
Oh man,
hearing,
Chris, how did you know what happened to me last weekend? How did you know?
it's almost like it happens to everyone that goes skiing. So I just never became a winter sports fan. Like I'd rather fall in water than fall in like heavy ice. That's maybe a hot take around here. But okay, we got the quadrotor going, right?
All right. So let's see.
Cool.
What this is doing.
Well, it's actually tracking it pretty well.
It's
Yeah.
actually tracking pretty well. Yeah. Well, the wind intensity is a light breeze.
It's
so
pretty low. Yeah.
Let's give it some more wind.
Storm mode.
And all right, so I'm holding my controller up here. Hold on. Sorry, I'm new to the streaming thing, so I still got to figure out like how to hold this controller so people can see it.
Yeah. Otherwise, people are gonna think that you're faking it. We're reusing a task, and the speed run is not going to count on speedrun.com.
Ah, no.
You need to get one of those cameras
much
that
for my
points
internet
down
fame.
at your
All
controller.
right, so the very cool thing here is that whenever the drone comes close enough to the waypoint, my controller actually shakes.
Ooh,
Yeah,
that's
yeah.
pretty
So,
cool.
so I can sense when my strategy is having good vibes, right? Okay, let me change the perspective a bit here, just so that
We
you
should
can
really
see.
make sure while you're playing with it, we should make that drone model a little bit larger. No,
Yeah,
really,
yeah,
no,
that's a
like,
good point.
it's like a fully rendered, like
It's like
it
a
has
single.
every
Yeah,
rotor
yeah.
and
True.
everything,
Well,
but it looks
let
the
me tell
size
it to
of
do
like
that.
a
All right.
fly.
Well, okay. So right now it's got 0 context, so I'm just going to force it to compact, and then I'm going to say, just going to queue this message up. Make the drone model a bit bigger because it's really cool and we want to see it. Again, some downsides of dictation.
Wait, you want it to be bigger in the visualization, not physically bigger
yeah,
in
that's
the
true.
sim, right? Make sure you, yeah.
Mm-hmm.
In the dashboard visualization because it's really cool and we want to see it. All right. Alrighty, so let's see what the agent thinks of our conversation, right? I'm curious to see what this conversation summary is going to be. So it's got the original request, it's got a list of things that it's done. All right, it's telling us about now the new motor dynamics and the PID controller, updates that we've made, interactive waypoint system integration, all right, updated dashboards and so on. Alrighty, very cool. Okay, so the scale is slightly bigger. Alrighty, run the script again. I'm going to close out this Claude session. Yep. Oh dear. Ah, no. Why is it doing this? No. Okay, so the agent, okay, it figured it out already, but yeah.
This
It should pop
whole
up.
method reminds me of like how Roomba cleans a room. It's like it goes bumps into things, and then it's like, oh, oh wait, that's a wall.
Hey, whoa. With the recent version, we have a map. It keeps a map of your house. Just like the drone keeps a map of your house. In particular, John, it has a full complete map of your house for some reason.
Alrighty. Not quite open yet. Give it a couple of seconds to get going here. Ah, there we go. Ooh, very nice.
Yeah, there we go.
All right.
That is very
Alright,
cool.
I'm slowly fleeing from this drone, which seems to want to catch me. All right, and if I sit around here for a second, whoop. All right, so now,
Put the controller in your microphone. See if we can hear the rumbles.
anything?
No,
No.
no.
Nah, the wind. Something just said. Well, anyway. All right, so we're now at strong gusts. I'm
Storm
keeping
mode.
it going,
Storm
but
mode.
all right, I don't think it's gonna. I don't think it remembers storm mode quite yet.
Oh, it doesn't remember
Oh.
storm
It
mode.
doesn't remember
Okay.
storm
Oh
mode.
no.
Boo.
We need to escalate this to Anthropic.
All right, so let's see. I can snap the heading. Oh, that is very cool. Okay, so I can click on directional buttons to force the heading to a particular angle, which is very nice. And then I can also change the altitude. Haha, catch me now. Aha. All right, and then I can also pause and restart. All right, so I don't know if you can see this, but you can kind of see the LED lights of my controller changing a bit.
Mm-hmm.
So that's also an indicator of like how close the drone is to the controller. Or to the waypoint rather.
Whoa.
Yeah, 4 more prompts and you have a game.
Yeah. This is pretty sick. I gotta say, this is pretty sick.
Does the mean have? Does the wind model have a sort of like an expected 0 random walk? Okay, makes sense.
I think so. It depends. So one of them is the Dryden wind model, and then one of them I made like a Dryden-like wind model, but where you can control the noise on each axis. I think this is just the regular Dryden wind model, if I recall correctly. And
I think because Dryden sort of the coefficients on each axis are lopsided. We decided that we'll normalize the wind on to be equal on all 3 axes, so it doesn't look weird and sort of jumpy.
Yeah, I just asked because it's giving. I think that's causing the controller to have a little bit of an easier time with respect to wind up, for example, in saturation, since the on average the wind will eventually average out to 0.
Very possible. Yeah.
Because
Go ahead.
I imagine the waypoint tracking error here is mostly due to the wind model.
Yes.
Yep.
So Ben, are you saying that if the wind model were to be like, there's some component of wind which is constant in one direction, added to the existing turbulence, are you saying that the PID would have a harder time tracking that?
Yeah, exactly. Because right now what's happening is that it's only ever having to fight it so much in any given direction.
I see. Okay.
Since the wind will change direction, since the wind will drift in another direction, but in the time that it takes.
So the PID controller can actually just sit there and theoretically it could not do anything, but
also,
the drone would always be forced towards the waypoint because the wind is going to bring it back.
Yeah, but it also looks like have the motor models actually been sort of incorporated? It looks like the older sim with the thrust and with the idealized sort of thrust and moment.
It could just be that there's sufficient control authority in this regime.
At 7.8 wind intensity in storm
But what
mode?
does that
it's around 1 to 2 newtons. It's not super high.
Oh, okay.
Yeah, so it's less than 10% of thrust. So yeah, we have plenty of control authority. Are we sure that the wind intensity is in meters per second, or what unit is that in?
So I have no idea what unit this is, but there is a wind force.
Yeah. Okay. I see it. Okay. 1.2 newtons. Okay.
It sounds like you might want to start bringing in that real data and start telling
the real data was from a windless environment, so it wouldn't. It's not useful here. But we're using less than 20% of control authority here, so it makes sense that I mean, the obvious thing to do here would be to ask the agent to plot the motor
all right,
states.
we're now in storm mode. All right, so Ben, what magnitude would you say we should get the wind up to? Like, oh, it doesn't let me go above 12.
I don't have any frame of reference for what values it's reporting
Yeah,
here, so I
fair.
don't.
Yeah.
Well, you can see now that it's finding it kind of difficult for sure.
This is actually really good.
Reset this for a sec.
I think we should try to incorporate some real data into
The wind
Yeah.
the wind is actually less right now.
Oh,
That's true.
oh
It
yeah.
doesn't. Oh, yeah. I think it just didn't update when it reset. This is the problem when you have an
Storm
AI create
mode,
a game.
storm mode, storm mode, storm mode, storm.
Boom.
Storm.
All right. All right. So altitude and yaw. Then. Oh man, I am having a terrible time controlling this.
Yeah, we're approaching about 50% of available thrust.
All right, so we're getting an ask from the Twitch here that on-screen diagnostics would be nice though, as Ben said. So yeah,
Well, it's kind of got them here, but I don't know how.
So
feasible they are.
of like the controller states and of like the controller and motor states.
Okay. Yeah.
Yeah, well,
We can do
maybe we
that.
should ask it to create like a whole diagnostic HUD HUD or something like.
All right. What I can do is I can ask it on this side, which is basically unused screen real estate. I can tell it to create a HUD-looking diagnostic panel for. All right, let's get a prompt together.
Mhm.
On the left panel, which is currently empty, I want you to create a HUD-like diagnostic of the controller and the control actions. Is there anything that we should include here that it should be taken into account?
Motor angular rates.
Motor angular rates. And maybe also just some metric of like how close the motors are to saturation. All right, so it's going to go start that.
Yeah, it might actually be a good time to look at the model a little bit and see what the exact wind
Yes.
model is while it's doing this.
So, all right, so let's see. I'm looking at interactive. I think this is interactive. Oh gosh. Well, I guess the best way to do it is to start from the script. So the script is pretty long. Oh wow. This is about 1,000 lines of code. I'm sure it can be simplified quite a bit, but okay. So it's starting by finding the controllers and whatnot. Interactive waypoint test is the analysis that it's using. So all right. So it's using this test interactive waypoint component. So this has got the interactive waypoint follower, and then it's just got some noise sources with different frequencies, which are sine waves. So okay. So
well,
let's look now.
isn't that the wind sources being sine waves, right? Or wouldn't those be exactly the thing where it's going positive and negative with regular frequencies?
Yep.
So,
Which I think Dryden was
not very
also
chaotic
sine
wind.
waves. Not very chaotic wind. No, this is kind of a lie here. We could do Lorentz attractor wind. But let's see first if the diagram view sort of shakes out here. Okay, a lot of the connections are actually just like algebraic equations, so you don't actually see much if you try to overlay out this. But you can at least see sort of a list of all of the components in a visual way. So, all right, so we've got this controller, which I think is a PID controller. We've got the quadrotor model, and I don't know why the wind model has the quadrotor icon, but okay. Then we've got the model of the motors. So, all right, so let's go into the model of the motors for a second here. All right, so I right-clicked on this, and then I said go to definition. And then if I auto lay out this guy, oh, it's just some inputs and outputs.
Yeah.
Yeah, it doesn't have any components inside it, which is fine. All Alrighty, let's see what the.
So we got a question from the chat here. Is Dyad using Opus 4.6 already? It's actually still on Opus 4.5, I think, on your version,
Yes,
right?
still on
Yeah.
Opus 4.5,
Yeah.
but I believe that change should be coming soon to allow it to use 4.6.
Yeah, so hold your horses. But it's just a switch. It's really just a thing for the next release. I think, Anshul, you might not be on like the super dev version or whatnot.
I'm not on the super dev version. I'm just on 2.1.
Yeah.
But yeah, I think the next version is going to be 3.0.
Yep. Next version will be 3.0 coming out like in a week or so here. Yeah. I mean, I don't want to promise anyone. I'm not going to promise anyone live, but it's just really close. And that'll have a Modern Toolkit V11 in the system image, so we'll have much snappier compiles and such. So
awesome. All right, so it's found some issues in what it wrote, and it's now fixing those, mostly just variable scoping issues. Alrighty. We are now running something. Love the background soundtrack, Chris. You've got the bird chirping and all of that.
Oh yeah, sunny Southern California. This is the Cali show right now.
Yeah, outside my window is sunny, but I can't say I want to open it anytime soon. Sitting up in Boston, it's pretty cold. Ah, interesting. Okay.
The lift macro. What's the lift? That a Mach-E?
That's a Mach-E thing. I don't really like people using lift macros. I'm not sure why it's doing it.
How did this work the first time? Oh, I see. This is the HUD. This is the HUD state.
This is the HUD. This is the HUD states.
Yeah, that means you got to write more blog posts telling people to not use the lift
true.
macro, and then Anthropic will pick that up and put it into its next training data set.
I'm actually pretty surprised that it's got as far as it did with zero prompting on my part, or very, very minimal prompting on my part with using Mach-E. But hey, that just means that other people can do it too. So you can do this. You can try this at home.
Just make sure you wear a lab coat and only try this with the son that you want to sacrifice.
I know we're modifying the visuals, but the original request was to try to make the quadcopter more realistic with data, right? Like the actual behavior of the quadcopter.
Yeah, well, we'll get to that one. Yeah.
Right.
Okay. Let's get some diagnostics about whether we know we got this right first. But then,
yeah, understood.
Actually, in the meantime, maybe it'd be nice to show the video of what we have.
Yeah. Let me pull that up. I think I just downloaded that. Okay, this is actually, well, this is running the dashboard, but it'll take a bit, so I can show this. So I think, Ben, this is from your JuliaCon talk, right?
Right. So this is a flight that was done with the University of Washington Autonomous Controls Lab. This is sort of just doing a very simple circular trajectory where the where the quadrotor is being asked to follow a very slowly rotating point to validate that the controller works and that all of the trajectory is being tracked correctly.
Yes, we're gonna have to see if we can read this in and have it, basically have it match our model to what it sees in the video.
We also have ground truth data from the mocap system you see in the background, so we can evaluate the performance of the so it should be circle.
Circle.ulg.
Yeah,
right.
I'll note that, by the way, Anshul, did you get the other library? Yes, you did. Okay.
ulog.jl? Yeah,
Yeah,
I got
you'll-
that and I adapted as well.
Okay, good.
So what do I have to do here?
So most of that I sent you is just infrastructure for Kalman filtering based
Sweet.
estimation of the drone's estate. What I would suggest is let's first start with the video and then compare that against the ground truth. So we don't give the agent the data yet.
Okay. Oh, you're saying just give it the video and then see what it does?
Yeah, exactly.
Hmm.
Like if we give it the ground truth data up front, that's sort of spoiling the point, right? If we want to read it out of the video.
That's fair. That's fair. All right. I will warn you that trying to get an agent to do this will probably take some time because it'll have to figure out. Oh wow. Okay. All right. Sorry. The dashboard just came online. Ooh. All right. Ah, very cool. Okay. So you can see my controller input, right? Which is actually coming from the controller. You can see where both my joysticks are.
It looks like we've picked up a high frequency pole.
How do you mean?
So can you have it do so? Can you sort of have it do some aggressive maneuvers again, like change the set point dramatically? Oh, I see. No. It's just the consequence of the set point changing.
Ah, okay. All right, so I'm gonna get it into storm mode again.
So I think some of the tests that we're doing to validate this is probably why the wind, the magnitude of the wind is not that high, is that it doesn't want the test to sort of cause instabilities in the quadrotor. And so it probably scaled that specific part of the model down so it can validate its tests, maybe? Because
it's possible. It's possible.
Can you ask it to add a small parachute?
Oh, to the drone?
Yeah.
Yeah, why not?
It is distracted a bit from the
Add a small parachute to the drone.
Wait, actually, before you do that, and map it to a button on the controller.
Oh, and map activation. Yep. Oh, no. No, but you've got to model the parachute too.
Yeah, you can't just make visuals. That's not.
I was just gonna add it to the visualization.
Yeah, so we got a question here. So I missed that part, but how did Dyad figure out how to connect the DualSense to the simulation, or did you help it with that? Yeah, Anshul, give a bit more on that.
Yeah. So I kind of helped it with that a bit. What I did was I wrapped a C library that communicates with any what's called a human input device, or HID, right? So that could include your keyboard, mouse, a joystick, or in this case, a controller. And so I gave that library also had an example of how you can connect that up to one of these. And so I pointed the agent to that example, and I pointed it to the library that I wrapped, and I told it to create a framework which it can use for connecting this to a simulation.
Mm-hmm. And so that wrapper to the C code now, is that now just a open source Julia library anyone can use?
Yeah. Yep. So
Show
I'm going to publish that. Well, I made that last night,
okay.
But I'm going to publish that today. Yeah.
Okay, cool.
All right, so it's testing the parachute component. Okay, so the way it's done it is it's got a deployment fraction for the parachute. And so presumably you can take that from 0 to 1 whenever you like. All right. Interesting. So now it's actually, okay. So it's computing what the terminal velocity of the drone should be, or of this, I guess it's a weight connected to a parachute, should be. I forgot to use printf. All right. Oh, that's pretty good. So you can see that it's actually run the simulation and computed what it expects the velocity of the system to be, right? So I think this is just, let's see what it's done here. So it's got this component which is parachute dynamics, velocity and world frame and whatnot. And then you've got a test parachute deploy, which is connecting. Ah, okay. So the parachute dynamics, how does this work? Ah, interesting. Okay, so it's written out the dynamics manually. All right. But it's effectively connecting the parachute to a weight and then letting that fall. And
Because we didn't size it, right? You just said a small parachute. So
I just said a small parachute. That's true.
It doesn't know how big it needs to be, right?
That's
Relative
true.
to.
All right, so it's updated this interactive waypoint follower component. I don't want to auto layout it now because the agent is still going to edit it a bit. Alrighty, so let's have a look at this graphically. All right, so this is the parachute component. It's got one output and a bunch of inputs. Yeah, cool.
So at some point, it looked like the agent is using the quadcopter icon for a lot of new blocks. We need to tell it to make some blocks. We need to tell it to make icons for the wind and other stuff.
It's such a good icon,
true.
you know.
True. But it did make some pretty cool icons, I think, last couple of times, right? We've got this quadrotor icon, we've got this controller icon. So yeah, just got to get it to make some more icons.
Balanced.
I don't know. It seems pretty imbalanced to me. I mean, the thing is falling.
It depends on what you want the plane to do. Is it supposed to give you internal, you know, is it just to give you internal happiness, or is it supposed to fly, you know?
Well, you know, if the altitude depreciates at the same rate as the value of the plane, you've got something going there.
Ooh, okay, so it's going to use your L3, your left stick
right.
button as the. Okay, now this is turning into a whole game.
Yeah. I mean, hey, maybe this can be like a live demo for customers, right? We can put this up on the web and then just like ship them a controller and they can actually play the thing. Although the setup would be annoying.
Anshul, is that library for controllers? Will it handle a bunch of different kinds of controllers, or are they all unique?
Yeah. Any HID compatible thing. So I think definitely a joystick.
Xbox controllers, PS5.
Yeah. Okay. Xbox controller for sure.
Yeah, John's sitting there like, I want to use only an Xbox controller. I'm never using a keyboard again.
I happen to. My son won a raffle for an Xbox, so we have an Xbox.
That's
From your description though, it's working at the raw HID level, right?
Yes.
So you'll need to like update the descriptor parsing based on the hardware you have.
Yeah, but that's not that's why we have agents.
Oh, so it's actually having to update the Bluetooth driver in order to add this new button.
Yeah. Well, it's let's see.
It's at the level above that, right? So it gets the HID packet. So it gets the HID packet in from the USB stack functionally. But then what I'm saying is that like that state the Anshul is looking at would need to change based on your hardware.
Yep. Interesting. Yeah. Oh, okay. I see. So it's got this. It's got these parse input report and parse short report functions. Oops, did not mean to do that. Okay, so this is actually, yeah, so it gets the report as just a vector of bytes, and it's actually parsing the byte string that it gets into some reported state of the controller. Which is
What I
pretty slick.
find really interesting about this though is that it isn't actually using the descriptor. Like as part of the head attachment, your device will send, hey, here's what I have, here's what the order it is.
Yeah.
It's going rogue. It doesn't need any of that.
So ultimately, this is very specific to
True.
DualShock.
Yeah, we should. Well, that's why I said I haven't published the package yet, right? Because this is the crap that I need to clean up. But yeah, no, for sure, it's a good point. We should make it much more general. Alrighty, so it's updated
it should blink red or something saying you deploy the parachute, deploy the parachute. I don't want just help text. We want like a warning sign. Give us some urgency.
Well, I don't remember if this library works, but there is definitely a library probably that you can use to play audio from Julia. So yeah, you know.
Oh, you have to add the Warcraft 3 sounds, yeah.
I don't know. Can I do that on a stream?
The
Is that not like copyrighted?
The gyrocopter. Well, no, because a lot of video game sounds are considered not copyrighted because that's why they're able to stream them. Yeah. So if you got the flying machine sounds, the gyrocopter, that'd be perfect. Just saying.
All right. Worth a shot.
Let me see if I can find the file for you.
Send him over. Oops. All right. So this seems to have hit. It's the emoji. No. Don't use emojis in text. In marquee text.
Anshul, yeah, I sent you an icon for the wind.
Sorry? Yeah, it's enough for the parachute. It's using this emoji.
I sent you an icon for the wind.
You sent me an icon for the. Oh, awesome. Okay. Hold on. Let me grab that. Sweet. Alrighty, let's open this. Ooh, that is very cool. Okay. This I have to show the world. That is very cool. Alright. Alrighty, so what I'm gonna do is I'm gonna take that SVG and I'm gonna drop it in the assets folder. So this is now win.svg, and I can go into, I think no. Wind disturbance. Yeah. So I can go in here and you see it says icons, default, dyad, quadrotor components, quadrotor.svg. I just changed that to wind.svg. And so this dyad : / is just saying that, so it's a protocol, sort of like HTTP is a protocol, file is a protocol. And then it's saying, okay, so find the dyad library quadrotor components and find its assets folder there. And then within that, you put the path in. So in this case, the path is win.svg. And I'm gonna also change that here. And if you now look at interactive waypoint.dyad, there you go. Wind. Awesome. Yeah, thanks, John.
That's a nice looking icon.
This is crazy, huh?
You can thank the agent. I didn't do anything. You want an icon for the parachute too? I can do that.
Yeah, why not? The agent got a bit lazy. It didn't run the script, so had to make. No. Why is it doing that? No. This is like, okay, we got to fix this. It's not supposed to be doing this. All right, Chris has also sent the Warcraft flying machine quotes. Wait, so Chris, what do you want me to do with this? Like, you want me to just play a section of it whenever the parachute deploys?
Oh yeah, it was just like just have it just give off, kind of like how whenever you play the RTS, every time you click it, like it does one of the quotes, right? I couldn't
Ah,
find
yeah. All right.
separate though, so it's just one giant clip. So maybe we look the credit apart or something.
What's the flight plan? Where to?
Right? Isn't that perfect? Come on.
All right. Oh boy, come on. What is this doing? Okay, but it's saying that the DualShock didn't connect. Okay, let me disconnect and reconnect that. Okay. I turned it off and on again. Let's see what happens.
And he goes, oh, everything must be fixed now.
All right, so we've got the dashboard now. Just a sec. All right, okay. So first I'm gonna up the wind. I'm gonna get the wind up to the like about 9 or so, right? Which is where storm mode begins.
I mean, it would be perfect if, when this opened, it just screamed at you, what's the flight plan?
All right, we're now in storm mode, and now it's the L3 button. Oh? Oh, I love how it's clipping.
Inverted.
Wait, it's not letting me turn it off. No. Oh no. Wait,
that is a strong quad right there. There's a storm, there's stormy wind, there's a parachute, and it's just
right, I'm curious to see what happens. I'm gonna take this wind intensity to the highest possible, right? Wow, that's insane.
The wind magnitudes seem like they're on the same. Like they're the same as before, or at least it isn't. The parachute drag doesn't seem to be included in the wind magnitude.
Yeah, no, I don't think it is. Oh, you mean like the quadcopter is not actually getting the parachute drag?
Yeah, that's what it looks like. Or I suspect that the parachute isn't interacting with the wind, is my guess.
Mm-hmm.
Because it looked like if
I see. Okay.
Like it looked like it was falling slower than it used to.
Yes.
Like it looks like that it can't descend as well, which you would expect.
Okay, so if I actually let me reset this so it just takes me less time to decrease the wind. So let's make the wind 0. Right, and then what I'm gonna do is I'm just gonna take this as far up as possible. And then I activate the parachute, and then I take it as far down as possible. Yeah, I think it is a bit slower, but yeah, I think you're right.
Well, let's actually look at how it implemented that parachute.
Yeah. Let's see. So the parachute is here. It's got an input velocity and then an output drag force. Oh, you're right, Ben. Yeah. Yeah, it's only got the input velocity and the output drag force. But what it really needs to have is an input wind. So maybe it just needs to be hooked up. Right, so okay, so we've got a parachute dynamics here. And let's see. So I can search for the parachute. Ah, yeah. Okay, yeah. So the parachute's velocity is set to the quadrotor's velocity. Yep. Okay, so we need to tell the agent, you've connected the parachute to the quadrotor, but in reality, you need to give it the net wind force that it feels. So that's, I guess, the velocity of the quadrotor plus the velocity of the wind?
Seems reasonable to me.
So that was definitely a spot where we could have just did the plus ourselves, but it's okay, guys. You're looking at the exact line of code right there. It's like, you know what? Let's dictate this to the agents.
I thought the point of this live stream was that I don't touch a line of code.
I guess so. Yeah. But that's a certain level of laziness to go look at the
True,
line of code and be like, we should put a plus right here. Hey, agent, go put the plus right here.
Alrighty, this is now gonna double check the parachute is doing what we want. Yes, run the interactive script again.
It receives airspeed. Ah, that's the word.
Yeah.
See, if only we had someone who knew Quadrotor models, it would have told us to tell it to use airspeed. Good morning, Mr. Bird.
Don't make the birds mad.
Oh, they're watching this like, man, that thing is really able to fly in the storm really well. They're really interested now.
And with a parachute?
And with the parachute. Yeah, the birds are
and
pretty
lugging
impressed.
this cargo. Oh my gosh. Alrighty, we've got an interactive window here. Alright. So right now there's no parachute. I'm going
Storm
to...
mode.
What did I do? Wait, what? Ah, okay, okay. Alright, so I'm gonna make it storm mode first. I really should have made it give me a hotkey to just like go instantly to storm mode, but oh well.
Yeah, that's all we need. Storm.
Right, so now, woo, okay, that's buzzing, All right, now deploy the parachute. I mean, it definitely looks like it's, oh yeah. It's definitely being forced a lot. Like it's able to, it's like almost able to
let it stabilize around the point.
Stabilize, but only like it's only able to intersect the waypoint by happenstance, basically.
Sure, but I'm not sure that it's actually doing much worse than it was before. Like in storm, when we had storm mode on, this is almost exactly what it looked like before. I'll bet you that.
I think I was zoomed in a bit. No.
He's at storm 12 though. Maybe put it back to 12 and see.
Yeah, but that shouldn't make that much of a difference, right? That'll make like 20% of a difference, if that. Yeah, I mean, you can see that the motors are not hitting saturation.
Does it have the sign, the SIGN, right, for the parachute forces?
I think
because
so.
It should sort of act.
Let's see what the parachute is actually doing, right? So it's taking the magnitude of the velocity. It's getting the magnitude of the force, and then it's okay. So it's just inverting that with. So I think it's the force is directly opposite the velocity. So
yeah, I think
correct.
My suspicion is just that the scale of the parachute drag coefficient is a little bit too small.
It could be.
Or well, too small to be fun.
It seems that the scale of the parachute's drag coefficient is a bit too small to be fun.
You're gonna say now fun parachute mode.
All right, But yeah, I mean, so I think the mistake we made here was that we didn't sort of tell it the high level constraints, which was that we wanted the parachute to have a certain amount of drag and that, it should really have an impact on the trajectory of the drone. We just told it make a parachute.
All right, the drag force will be nearly 5x the drone's weight.
Oh boy.
That's much more dramatic. I like I like it. The RA likes some drama.
Alrighty. Well, what did it do? Oh, it just changed the parameter. That's it.
The AI is like on a RuPaul's Drag Race. It's like, am I the drama?
Sancho, I sent you a parachute icon too when you're ready for it.
Thank you. Thank you. All right, let's get this in here.
Oh,
Ooh,
perfect.
very cool. Okay, okay. All right. Did it get the thing out yet? Not quite. Ah, there we go. All right. First, got to get the wind up. All right, let's start at strong gusts, right? So it doesn't seem to be making that much of a difference. Keep the wind intensity going higher. Yeah, I don't know.
It definitely, I think that it is impacting a little bit more.
Yeah.
In that if you look at the motor angular rates, I think that we're getting a bit higher.
True. And you can see the saturation is getting a bit higher, but even so.
And to the comment, yes, I believe that our model at this point of the parachute is functionally a sphere. So we're effectively just adding a large balloon attached to the drone.
True. Well, it's just a drag source, right? Really, I don't think that we've even done anything crazy to it.
Yeah, I think that the next fun thing that we could try if we want to go down this direction would be adding an angular component so that the parachute tries to drag the drone off vertical.
Mm-hmm.
Ah, true.
And
I think that's probably what we're missing.
Yeah.
Oh boy! All right.
I think this is becoming balloon day. Yeah, we were going to get some real data, but it's balloon. The moment that we saw that on the screen, and it looked like a balloon, we should have just known. So, okay, yeah, definitely this comment here. Can you instruct the tilt of to tilt the parachute graphic towards the downwind direction?
All right.
Mixing that.
So what I want you to do is two things. First, I want you to tilt the parachute traffic towards the downwind direction, and
actually, can I suggest a different prompt?
Yes. 1 second. Let me delete this first one. Yeah. I don't think that you will be able to dictate directly. So just tell me the thing and then I'll say it.
So the couple the parachute disorientation to the drone's angular state, and assume that assume that the parachute can apply a moment to the drone.
And make
Couple
sure
the
that
parachute's orientation to the drone's angular state, and make sure that it can apply a moment to the drone.
And also show the parachute's orientation within.
And also show the parachute's orientation visually in the dashboard.
Not in the dashboard, in the animation.
In the animation.
Yeah, I want to see the parachute going like. And what happens when you're going up, but the parachute's below, or?
Yeah, probably. I mean, at that point, like
model the parachute hitting the actual drone itself, and looks like John entered emo mode. So yeah, so I'm gonna guess that we're not getting into the real data today. So we'll need to keep that for another time. but
Fair enough. Fair
you
enough.
know, I think for the last thing here, I think seeing if we could get this parachute to be
Yeah,
float.
let's get the parachute looking good.
Mm-hmm.
Also, it failed to. Okay. It's trying to create. It tried to create a new file, and then realized that there was already a file. So now it has to read the file in order to edit it.
Mm-hmm. Oh, did it delete from its context to the parachute?
I think it just it went out of context and kind of forgot that the
Mm-hmm.
parachute component existed.
Need bigger models.
Yeah. AI providers take note.
For review, can you discuss what model elements we started with and what was added through Dyad and Claude this session?
Yeah, so I think we started with we actually started with a pretty solid base. So we had a quadcopter model, we had a wind model, and we had an interactive sort of animation dashboard that you could. So the drone was tracking a waypoint, and you could change the waypoint using the keyboard, but that got pretty difficult to actually do. And so this time we decided, okay, we've got this controller. Let's use the game controller. And so now it is using the game controller to move the waypoint around. That was step one. Step two was then to add anti-windup to the PID controller and add some saturation dynamics to the motors of the quadcopter, so it couldn't just generate infinite thrust. And then step three was adding the parachute. And so we added the parachute, and now we're just trying to adapt the parachute so that it looks and behaves like an actual parachute.
Yeah, well, we might want to discuss a little bit more about the model itself. I mean, Rajiv, you started with the basic quadrotor model, but then we made it so that we added motor dynamics and yeah, I mean, give the whole sphere of that.
Yep. So we started with a pretty idealized assumption of the quadrotor, which is it assumes that the thrust and the moment can it just has infinite authority to make whatever thrust and moment commanded happen in the model. And so that's a little unrealistic. So we added on a motor model and some saturation. And because we did that, we had to update our cascading PID to have some sort of anti-windup. And then we plugged that back in to our interactive simulation. So right now, the little HUD to the left sort of shows the motor RPM commands relative to the saturation. And that is the motor angular velocities are our primary control input. And there's a linear map. So it's assumed that there is a linear map between the thrust and moment commanded and the angular velocities of each motor that we have, which is also idealized, but like a lot better than what it was before. And then now we decided it'd be fun to deploy a parachute in storm mode. And so then we essentially have we had a highly idealized parachute that sort of simulates drag forces onto the quadrotor that it's sort of attached to. And yeah, now we're trying to make that more realistic by aligning by coupling the moment of the quad to the force sort of experienced by the parachute. So yeah, that'll be interesting.
Yep, awesome, and perfect timing. I think this should be coming up in about a little less than a minute here.
Yeah, and we'll put up inside the Dyad demo repository. Yep. We'll put up the full demo. So if you want to start running this locally, again, the controller needs to be a DualSense controller.
Well, we also have an option. I'll clean this up so that you can also do it by keyboard.
Okay.
So you'll have sort of two alternatives.
But you'll be able to see the full model
Yeah,
and all the code behind the model and whatnot if you want to take the Quadrotor that we have and use it as a base for something else, or add some other bits to it. So
alrighty. Okay, so pump up the wind here.
pump up the wind.
Yeah, we should probably just have it go straight to storm mode at this rate.
Yeah.
We only want storm mode.
Yeah, like I don't think that we've ever increased the wind speed to anything that wasn't storm mode.
True. All right. So I wanna sort of get a baseline first, right? It looks like we're oscillating with an average radius of about 1 meter, right?
Yeah, if you look at the numbers in the status,
Yeah, it looks like about 1 meter, maybe a bit more. But let's call it a meter. Okay. So now I am going to deploy the parachute. Woo!
Oh,
So it's moving
yeah.
a lot more slowly. It's moving a lot more slowly, right? You can see that. Oh, I love this. This is like one of those classic Tom and Jerry things where it's just like it just can't. Whoa.
And look, we're really saturating the motors now. Yeah. It's,
Yeah. Oh wow. Yeah, you can see that, right? Yeah.
I think this is less of a parachute and more of a balloon. Like he's just
This is a
deploying a
balloon,
little
that's true,
balloon.
that's true. No, it's an ideal parachute, right? Like an ideal cow is a spherical cow, an ideal parachute is a spherical parachute.
I think that the wind may need to be subtracted away. I think the wind needs to be subtracted away because if you the parachute / balloon is operating 180 degrees out of phase with where it should be, right? Because if the drone is being blown around by the wind right now, right, we would expect the balloon to be downwind of where the drone is.
That's true.
Yeah, because
I see.
Yeah, because the parachute effect, its position is affected differently than how it affects the. Yeah, I see.
I think the parachute might actually be like it might actually just be putting the parachute in the opposite direction of the drone's velocity.
Oh,
but
that's possible.
I think that might need to be fixed in the dashboard, not necessarily. So let's ask the agent.
Can we look at what that looks like when you're not moving the drone around, when it's just stationary?
Oh yeah. Yeah. So let me ask the agent first. So how did you actually get? Oh, it's following the shoot deer vector from the simulation. Okay. But
the shoot deer vector.
Yeah. So if I search for that,
the shoot deer vector.
Yeah.
Oh shoot! Okay. I thought this like some like American military terminology, like the shoot deer vector. It's the vector.
It's open season. It's open season on all these deers.
Oh boy! All right. So what is it doing? It's got a derivative. So the derivative of each positional component.
It just added a first order filter.
Ah, okay, interesting. But why? Huh.
To make it sort of smoother to view in animation.
Well, it says it added it so that the parachute will align with the airflow.
But that's, I mean, couldn't it just, oh, I see, okay, because it takes, I mean, presumably it should have some lag time, right? Like it shouldn't immediately move to the direction of airflow, but even so. So Ben, what exactly was feeding off to you about this?
The balloon, when the drone is being blown around by the wind, the parachute is running behind the drone, right? Whereas if the drone and balloon are being blown around by the wind, then the parachute should be pulled ahead of the drone.
So when the drone's getting blown around by the wind, the parachute is showing itself to be behind the drone, but actually if it's getting dragged around by the parachute, then the parachute should be ahead of the drone.
Well, so the YouTube comment here, maybe we should take their piece.
Yeah.
Instruct the parachute to tilt in the net relative downwind direction.
So you should instruct the parachute to tilt in the net relative downwind direction. Yeah, that makes sense. No, not downward. No.
That seems like a problematic dict.
Yeah, so it points opposite to airspeed. All right.
Mm-hmm.
Yeah, and you can see there that the input vel should be subtracted.
Yep.
That's so much easier to figure out when you have an animation than if you would have had to figure that out just by
True.
by looking at the traces, right? So
yeah, all you need to improve your modeling, kids, is to just hook up your things with the PS5 controller and play with it a little bit. Like, Mom, I need a PS5 controller. Why? For school.
for my homework,
For
so
my
I can learn how to code.
I need a PlayStation for my homework.
Oh wait, Chris. So does this mean we get JuliaHub issued PS5s?
PS5, yes.
Damn, I should have waited. I should have extorted you, Chris. No, I should have extorted you.
Yeah, you
It's a
don't
missed
need
opportunity.
you don't need the government issue PS5. You know, you're okay. You've already hit your quota.
I took the hit for the team. All right.
All right.
Let's see.
Storm and then moment of truth.
Moment of truth.
Storm mode.
All right, I'm gonna deploy the parachute now.
I think for the next one, you should just have a toggle on top that's like set it to storm mode or something.
All right, so the parachute direction at least looks a bit better, but I think the predictableness is just a factor of like the wind model that we're using.
Yeah, so on the stream here, there's a question. Can you describe the interface / integration between Dyad and Claude? Is it just a simple in-out piping between the two? Is there a more sophisticated interaction? So the Dyad agent is actually a completely separate agentic framework from the Claude Code. It's using a Claude model, but it's not using the Claude Code agentic system. Oh, did you hit the ground or something?
It lost control of the angular state.
Interesting. What happens if I decrease the intensity of the wind? Does that help or no? No. Oh, no. No.
My suspicion is that the attitude state has sort of devolved beyond the ability of the simple PID controller to recover. It's not truly a linear system. So in extreme conditions, it'll do this.
It's finally lost control. I see that as a win, actually. Oh my god, the things we've subjected this poor little drone to with this linear controller.
All right. I'm gonna reset this for a sec, and just so we can increase the wind and try that again, right?
But yeah, so I mean, just to mention back to the commenter, right? So if you want to hear more, I think that the folks from our AI team will be giving a talk probably at the next JuliaCon or something. I mean, we'll have to see how it scopes out, but we'll be talking a bit more about the agentic framework and such that we've been able to build. But it is a custom agentic framework, so that way it has full access to our compiler, full access to the internals of the solvers and such, and it uses all this during the debugging process. So because it's still kind of very new, we haven't shared much of the architectural details, but we will be planning to share a bit more about what we've done here. Because I mean, we're pretty excited with it. It seems to build some pretty usable models right off the bat, but it's definitely not using the Claude Code stuff, and so it's a much more sophisticated integration.
Oh.
So now there's another. Can you instruct the parachute to act on the CG of the quadcopter so that the quadcopter's attitude is directly affected?
Is not directly. Yeah.
The CG. What's the CG? What's the CG?
Center of gravity.
Center of gravity.
Oh, okay.
All right. So what was the question here? Okay. I see. Interesting. Yeah.
Yeah.
Okay.
So earlier I suggested that we attach it not at the CG so that the parachute would try to drag it off. But yes, let's decouple that.
Yeah. All right. So first thing, I want you to give me a hotkey somewhere on my controller that takes me straight into storm mode with like the maximum wind. Secondly, can you instruct the parachute to act on the center of gravity of the quadcopter such that the quadcopter's attitude is not directly affected by the parachute? Oh, oh, you didn't catch that? Oh man, come on.
Boo.
All right. First of all, give me a hotkey that takes me straight to storm mode, 12 wind, all of that. Secondly, instruct the parachute to act on the center of gravity of the quadcopter such that its attitude is not directly affected by the parachute. All right.
Okay, you know what we were talking about with some sound effects we need to add. I do think that we need to like in Suno like generate like a "I came in like a parachute" as we launch the parachute. So maybe we could go edit that in a little bit.
And that's a copyright strike. We're
I have
off
so
of
many
YouTube.
copyright strikes on the channel. It doesn't even matter.
So, but copying is correct, right? That's what it means, copyright.
Well, I mean, for this channel, we should only be doing copy left.
Ah, true.
All right, that's a GPL licensing joke for those who don't do software licensing. Okay, that's a small community.
I think the next thing on theme would be to have a payload of an Intel CPU.
Oh man, the Intel CPU. All right, so this is a joke from like a couple of live streams ago, right? Where we had a house and we were trying to model just a house in winter and the thermal dynamics of like how it loses heat and then how you have to activate a heat pump to gain heat and then all of this stuff. But of course, we added an Intel CPU there, and that basically removed the requirement for any sort of heating because Intel CPU.
Yeah,
Instead of buying a space heater, I bought an H200.
Hey, there you go. Well, it serves two purposes, right? It does something useful, and it's also a space heater.
Yeah, all these data centers trying to figure out how to cool. All that they had to do is they just had to distribute these graphics cards to kids well, in the Northeast or in the northern U.S., right?
Yeah.
And they'll get the natural cooling effect.
No, but I think Rajiv, right? Do you think that this would be a very hot item in Texas? Because think about it. The
You don't
moment
need hot
that
items
anyone
in
gets no, think about it. The moment that you get a cold snap, people are going to be panicking, and in the panic buy, you say, okay, flash sale, buy an NVIDIA H2000 that we can
Oh yeah,
use.
that is definitely real. Like every time there's like some news about like in Texas, it's gonna be maybe like 5 degrees cooler than it is. All the toilet paper from every Costco in known radius gone. All the milk is gone. All the eggs are gone. They never come
all the
back.
guns are sold. Yeah.
Who's hoarding on to milk, toilet paper every single time? It happens every year. It's like wow, how long do you think you're gonna be snowed in?
I think we've had some new people join, so you should show them that we have this all hooked up to your PlayStation controller, right? And
Yeah. So
Mm-hmm.
I've got this PlayStation controller here, and the interactive window is ready. So a live stream is worth 1,000 words.
Mm-hmm.
And so we've got this. So basically, we've got this quadcopter, and we've got a waypoint, and I'm controlling the waypoint with my
and it's fully modeling the motors. There's a PID controller with anti-windup that's actually doing the stabilizing. Then we're controlling the waypoint to try to send it to. Yep.
And all right, so now I'm going to hit the hotkey. That took it to storm mode.
Woo!
And now let's make it a little less stormy, right? Just the border of storm mode. Okay. And now I'm going to deploy the parachute. So, all right. That's interesting. It's actually a bit smaller. Well, okay. Let's take it back to maximum storm mode. And then I'm going to move this around. See what happens.
Any way the wind blows.
Oops. Wait, what did I do? What did I do? Oh gosh. Ah, there we go. Okay.
Excuse me.
So you can see that we've got this little heads-up display here, which is showing us also the angular velocity of, or the sort of RPM of each motor, and then also the saturation on the PID controller. And so you can see that as I sort of change direction very quickly, the PID controller begins to saturate.
Mm-hmm. Well, the PID controller, the controller output saturates. Yeah, yeah.
Right, right. Woo!
All right, boys. I think we got ourselves a quadrotor.
So we do, so we do. And this is actually control. So I think that the attachment to the center of gravity sort of made the parachute like a bit more stable. Right, because now you can see that the motor angular rate is pretty reasonable. The saturation that the PID controller is outputting is pretty reasonable. And yeah, it's sort of inscribing a tight little circle. It's a bit too tight, actually.
Need more of a storm, yeah. But I wonder if I mean, we're getting pretty close to the point where we can maybe mix this with a synchronous compiler and actually have a code gen and try something out. I don't think that we could do that with the quadrotor model, because the quadrotor we're going to need different hardware. But we are building out this Dyad bot, so maybe in one of the next live streams, we're getting pretty close to. Actually, Ben, you're working with the early Dyad bot stuff, right?
Yeah, the hardware probably is going to take a little bit longer, but we can definitely show it in sim.
Mm-hmm. Okay, so maybe you might want to show live deployment of modifying the code and putting it to the bot, maybe sometime in March or something.
Yeah, I think so.
Yeah. Well, the next immediate target is going to be controlling this like inverted pendulum thing that we've got. But that's a little bit boring to have on a live stream.
Mm-hmm.
I don't know, that could be like 1/2 of a live stream. But that'll be pretty in-depth as to like, okay, this is how this is how you do synchronous programming in Dyad and all of this stuff.
Well, but I mean, if we get this the synchronous programming set up with the agent, then for the most part we just tell it what to do, and then we have the control system set up as a synchronous compiler thing, and it's just outputting C code, and we could just make sure that we have we might want to have the runtime for where the C code goes set up and before the live stream, but then we can run little simulations and then kick out the code and then see what actually happens on the bot and just go back and forth between them live, and see how well we can vibe code it to just improve the actual hardware with that, right?
I think the pendulum is probably actually going to be a pretty good early example for that, because it won't run away from you. Like one of the problems with the Dyad bot, which for context is a self-balancing 2-wheel robot, think a Segway, is that it does have a very strong tendency to run away. So like
run away. Yeah, I mean, yeah, okay. So we just need to put it in fine walls, and I mean, I'd be happy to just keep on running after. I might be sweaty by the end of the live stream, but well, actually, you'd have the hardware. I'd have to fly it over to the source in order to have that. But okay, I think we're about at the end of this live stream.
Yeah.
I think that this is a cool demonstration. I like where we end up with the parachute. It's not where we expected to be going at the beginning of this at all, but it ended up being a cool place to go. We'll find out our topic next time. If anyone wants to give us topics to play with, just send a message on LinkedIn, send a message through email or whatnot. We're happy to just chat with anybody. But yeah, so I think that we'll be doing the robot models probably in the March timeframe. We'll have to figure out what we're doing the next Friday and the Friday after that. But we're going to be here every Friday. So I think we're signing out. Thanks, everyone.
That's the plan. Thanks, everyone.
Thank you.